Okay, so here we go. You can see I have two VMs running. On the left is the ground consultation VM, and then on the right is the drone VM from before. And these guys are connected through a through a routed network. I have two different USB Ethernet adapters, Wi-Fi adapters, and one's associated with each of these VMs, and they're connected through a portable router. You can see that they have different IP addresses, and they're both operating at the same time on the same shared network. So I'm going to go ahead and start the drone simulator. Similar as before in the DroneVM. This time, however, I'm going to add an output from to allow it to connect over UDP IP to another machine, and I'm going to specify the IP address for the ground control station machine. And as you can see, we're using the standard UDP port of 14550. Once that's done, I'm going to go ahead and start my my ground control station as well, with it being the master at its own IP address. So you can see this time it doesn't bring up that console that's associated with the drone simulation or the actual kinematic simulation that's running in the X terminal for the drone. But I do have still the same command line interface from MAVProxy. So I'm able to go ahead and start the engines, telling the drone to take off to an initial height. You can see it's, I think I specified, 40 feet. So you can see it's going up, it's climbing up to 40 feet. And I'm going to go ahead and use my map interface here on the ground control station to specify a point for it to fly to. And you can see that it's flying to that direction at a blazing speed of 5 miles per hour, which is what the limitations for this drone are. And again, with the quadcopter, much like the fixed-wing aircraft I demonstrated in the last video, we can specify the parameters for the drone any way we like, so we can make a bigger drone or more powerful drone or faster drone. And then I just went ahead and changed the destination point in flight. You can see the drone responds and follows. I'm specifying a higher altitude for this next waypoint, so you can see that the drone is going and increasing in altitude as it approaches the next waypoint. Actually, it's not really a waypoint, but the specified destination point. And like with the fixed wing demonstration, I could build a track for it to fly along and have it automatically follow that predetermined path. But for the purpose of this demonstration, I just like doing this manually. Alright, so I went ahead and gave it the RTL command, so it's going to return to its launch point, and with the quadcopter that means it's also going to land and shut down. So we can observe that. Yeah, with the ArduPilot, or I guess in this case the version is the ArduCopter, there isn't a separate land command to put into a landing sequence. So RTL just has it return to its launch point and land and shut down. And you can see the little quadcopter doesn't have nearly the kind of flight life that we had on the fixed-wing aircraft, because again it's simulated to be a lighter kind of a small quadcopter. So I'm already down to 60% battery power. And you can see now the altitude, we reached the launch point, just hovering over it, and now it's just descending gradually. Alright, so it just reached the ground there, and that's the engine shut off, so the rotor stopped spinning, and we're back at our initial starting point. So I'm going to go ahead and put it back in the guided mode, go ahead and restart the engines. And I'm just going to take off. Yeah, just to 10 feet. Give it a waypoint to fly to. Specify 20 feet. So again, you can see it's going to climb as it moves towards that waypoint. I'm already down to 40% battery power, so I wanted to play around and show you some other modes of this thing, but I'm not going to have a lot of battery life to be able to do that. But we'll see what we get through here. So I'm going to go ahead and specify a circle radius of 2,000 centimeters. And then I'm going to go ahead and put it in a circle mode. You can see it's starting to circle around, and just kind of spiraling down towards the ground. But I really didn't have the battery power to do a complete circle, so just reinitiated the return to launch sequence one more time. Alright, so this again is a simulation of UDP over IP, where we have a separate machine controlling the drone, and then the simulator responding and acting like the drone OS, as well as the providing the JSBSim kinematics. So we could input wind and whatever, but this allows us to simulate that Wi-Fi communication between the drone and the ground control station. And ultimately we'll put this into the cloud so that the ground control station could be remotely located anywhere, and different people could access the drone simulation and then be able to carry out these functions as part of this project. My next demonstration, I'm going to show you how I can use a different ground control system rather than a MAVProxy and the whole MAVLink setup there. So I'm actually going to use Mission Control, I think is the program, and that's a Windows-based program. I'm going to use the same DroneVM to demonstrate that, so look forward to having you check that out.